Good morning, everyone. Today we're going to talk about complex numbers and how to add them, multiply them, um, subtract them, and divide them. Okay, so I'm going to start with showing you what a complex number looks like. The standard form of a complex number is written this way. Okay, that is I, and I is equals to the square root of -1. Okay, so let me check briefly if this is being recorded. It is. Beautiful. Okay, so before I get to the heavy part of this section, I want to give you some examples. For instance, we know that the square root of 4 is 2. That we know. But what happens when you have the square root of -4? What is that equals to? Okay, so this is equals to -1 times 4, which is equals to square root of -1 times square root of 4. Now we know that whenever you see the square root of -1, that is equals to I. And then square root of 2, the square root of 4 is 2. Now we don't write it I4, we write it 2I. We don't write it I2, we write it 2I. Okay, so this is how you handle when you have negative radicands inside the square root. Okay, this is what a radicand looks like. Whatever is inside the square root is called a radicand. All right, let's do more. Let's say you have square root of -8. All right, so let's break this down. See, all of that is equals to -8. Then because of the negative inside the square root, you know you're going to get an I. So you're going to get an I. Okay, so that means that our answer would be square root of 4 times square root of 2 times I. And then you continue. Now we know that the square root of 4 is 2. The square root of 2 will remain square root of 2. There's nothing that we can do to it. And now we have a choice. We can put the I here, or we can put the I between the 2 and the square root of 2. Either way is perfectly okay. So this is where the I comes from. Now from this, we can write I squared is equals to -1. So whenever you see I squared, think that that is equals to -1. Okay. Now, what to do when you have I cubed? How to handle that? All right, so I cubed is the same thing as I squared times I. By the way, this is the way that I do my I with a little circle at the top. Okay. So now we know that I squared is -1 times I. So the answer is -I. Let's say you have I to the 4th. Well, what is that equals to? I squared times I squared. And each I squared is equals to -1. So when you multiply two negatives, it gives you +1. Let's continue with this idea. What is I to the 4th? Sorry, we did that already. I to the 5th. Okay. Well, we know that I to the 4th times I to the 1. Okay, this is I. I don't need to put a 1 in there. Okay, and I want to make sure that this is clear, that you do not need to put a 1, but I will, because 4 plus 1 equals the 5. That is there. Okay, so now I squared, we know from before, I to the 4th is equals to 1. So this is equals to 1 times I. So the answer is I. That means that I to the 5th is equals to simply I. So this is a problem that is going to come up in Alex. Let's do one that is a little bit more complicated. Let's say that you do I to the 20th. Okay. I repeat again, my I, the way that I write it is that I write I with the little circle at the top. Okay, you don't have to do it like that, but that's the way I do it. So how do I do this? What would be the easiest way to do this? Using what we already know, then I can do this. This is one of the rules of exponents. This says that you're allowed to do this, you see? In this case, you multiply here. You get m times m. Now, in this case, we already know that I to the fourth is equals to 1. All we have left now is 1 to the fifth, which is 1 times 1 times 1 times 1 times 1, which is equals to 1. The exponent tells you how many times you're going to multiply the base by itself. So this time the base is 1, the exponent is 5, so you're going to multiply 1 by itself 5 times. In this case, you get 1. Okay, let's do one that is more difficult. What about, let's say I to the 50th. Okay, well, what is I to the 50th? Okay, let's do this. I squared, let's say 50. I'm thinking right now, okay? How do I break down 50? 50 divided by 4. No. Let's say we do 50, 25 times 2. Okay, so this will work. You see? Now we know that 2 times 25 is 50. So there is my exponent. That's how I break it down. Now I squared is -1. And then I have -1 raised to the 25th power. Now what is that equals to? Now I don't want you to write -1 times multiplied by itself 25 times. That would be ridiculous, right? But we do know that 25 is odd. So if the base is negative and the exponent is odd, my answer will be -1. And you're done. You see? Let's do this one. I to the 41st. How do we handle that? Let's do it like this. This is the same. You see? 40 plus this one gives you 41. Okay, notice that this time I'm using this formula. Okay? I'm using a, and this time you add the exponents. On this one, you multiply the exponents. Okay, so that's the difference between the two. You multiply the exponents. So in this case, well, I is I. Okay, so that's just I to the first power. What about I to the 40th? How do we break it down? Let's do I squared, all of it raised to the 20th power. Okay, so what is I squared? I squared equals to -1 to the 20th times I. Well, this time you have a negative number, which is -1 raised to 20th, but 20 is even. So in this case, because the exponent is even, this -1 turns into a +1. So you have 1 times I is equals to I. So all of this stuff that we just did, I raised to the 41st power will be just simply I. And I shall show you how to do it step by step. Okay, these are the exponent rules that you have to remember. Okay, exponent rules. Okay, so now that we know what I is, then we can do the following. Let's say that I give you a number. Remember that our goal is to write them in standard form. And I say, okay, here's a number 2 plus 3i added plus 1 plus I. What is that equals to? Okay, so this time we're just adding. Now, One thing that I didn't tell you is that the A is equals to what we call the real part. And the BI is called the imaginary part. Okay? The BI is the imaginary part. So when you're adding, you're going to add 2 plus 1 gives you 3. You add in the real parts, and then you add the imaginary parts. 3i plus I gives you 4i, and you're done. Now, if you ever wonder, can I write them this way? Well, this is not in standard form, and we don't want to do that, okay? So you first write the real part, followed by the imaginary part. Let's do one that is subtraction. Same idea. You have a complex number subtracted from another complex number. Let's say you have those, okay? Before you do anything, you have to take care of the signs. So how do I do that? I'm going to get rid of the parentheses, and I'm going to multiply it negative times positive, negative 4, negative times negative turns into positive 3i. When I get there, then I remember that I need to add the real parts together, so that would be negative 2. And the imaginary parts together, that would be plus 4i. Remember, 2 minus 4 is negative 2. And I plus 3i gives you 4i. So there you have an example where you're subtracting two complex numbers. This example here, you're adding them, okay? Let's do an example where you multiply them. Let's see what that looks like. Okay, so let's say that you multiply 2 plus I times 3 minus, I don't know, let's say 2i. Okay, so this time we're multiplying them. So let's see, this will be 3 times 2, 6. 2 times 2, negative 2i is negative 4i. So you multiply this number times this, you get negative 4i. Then you do I times 3, which will be 3i. Then you do I times negative 2i, you will get negative 2i squared. Where did I get the I squared? It's when you multiply I times I gives you I squared. But remember, I squared is equals to negative 1. Okay, so at this point, I have to be careful how I do this. I'm going to go ahead and add those two. That will be negative I. Negative 4i plus 3i is negative I. But then I'm going to do this. When you see I squared, replace it with negative 1. And now, I'm going to multiply these two negative numbers. And then finally, my answer will be the real part plus the real part, 6 plus 2 is 8, minus I, which is the imaginary part. So this is how you multiply them, okay? Let's do another one. Let's do another one. Okay, so we're multiplying complex numbers now. Alrighty, so let's say 4 times 3 is 12. 4 times negative 3i is negative 12i. Then here, negative I times 3 is going to be negative 3i. Negative I times negative 3i will be positive 3i squared. Okay? Remember, negative times negative, positive. But you still have I times I, which gives you I squared. Once again, I squared is equals to negative 1. All right, so now I'm going to do this a little bit faster now. So this will be 12 minus 15i. Now this will turn into plus 3 times negative 1. Then you multiply those two signs and you get negative 3. And your final answer will be 12 take away 3. Okay, that gives you 9 minus 15i. Now, it is possible that Alex will say, identify what A and B are. Remember that this is the standard form. In this case, in this example, A is equals to 9, and the B is equals to negative 15. Okay, and of course, I is equals to I, so you don't need to write that. But the answer is here. This is the standard form of a complex number that we got through multiplication. So the foiling system is the same thing that you've been doing before. What is new is the fact that now you have to keep an eye on the I square, and wherever you see an I square, you're going to change it for a negative 1, and then you go from there. And at the very end, make sure that you write it in standard form, this form, okay? It could be a plus or minus in the middle, but what matters is that you write the real part first, followed by the imaginary part, which is the part that contains the I, okay? All right, so what about division? How do we divide them? How do we divide them? So let's say that you have this. Okay, let's say you have those. And the instruction is write this quotient in standard form. Because right now it is not in standard form. So how do we do that? This is the trick. Multiply top and bottom by the conjugate of the denominator. Here's a word that you may not know. Conjugate. Conjugate. What is the conjugate of the denominator? Okay, so this is new to you. The conjugate of the denominator will be equals to this. Notice that everything looks the same except that the sign in the middle will change. Since this is a positive, the conjugate will have a negative, and vice versa. Okay, so I'm going to multiply top and bottom by the conjugate. Remember that the beauty of the recording is that you can watch this again, and you can forward it, or you can rewind it and watch it again. This is the key. The conjugate, I'll repeat again, is everything is the same except the sign in the middle. Not the signs in the front, the sign in the middle. All right, let's see what we end up with here. Now, this time I'm going to multiply the bottom first. We're going to have a giant multiplication. So 3 times 3 is 9. 4 times negative 4i is negative 12i. And then I do the 4i times 3 is 12i squared. Sorry, just 12i. Okay, that's a horrible 12i. Let me erase this. And then I do 4i times negative 4i will be negative 16i squared. Okay. Then I'm going to go back to the denominator and I'm going to simplify it. But before I do that, I want to multiply now the numerator. 3 times 2, 6. 2 times 4, negative 4i is negative 8i. I times 3 is 3i. I times negative 4i is negative 4i squared. So now we're going to simplify this as much as we can. Okay. All right. Notice in the denominator, when we simplify it, the middle terms cancel. And the reason, pay attention closely to this, please. The reason why the middle terms cancel is because you multiplied two conjugates. That's the reason. That's a rule. Okay? The rule is this. Okay? That's a formula, if you will. Okay. All right. So now, what happens to my middle terms? Well, they cancel out. You see? I wrote them for you so you can see that you still have to FOIL. But if you remember that when you multiply conjugates, that those middle terms will cancel anyways, maybe that's a step that you can skip. But if not, write it out. Okay? Now notice that on the top, since we were not multiplying conjugates, that is 2 plus I is not the conjugate of 3 minus 4i. They're not conjugates. Therefore, the middle terms on the top will not cancel. All right. Also, I'm going to substitute I squared with -1. So this becomes -1. -1 times 4 is plus 4. This plus 4 now will be added to the 6, which is why you get a 10. 6 plus 4 is 10. Then you have -8i plus 3i, it will be -5i. So that would be my numerator. It's a little bit messy, but you can follow. Let's do my denominator. Well, my denominator, I already canceled the middle terms. And this I squared will turn this -16 into +16 because of this reason. So that +16 will be added to the 9, and that will be 25. So notice that at the bottom, you end up with a single number. Just a single number. The i's go away because the middle terms cancel, and the I squared turns into a -1, which I then multiply the -16, and that +16 now added to the 9, that's where I get the 25 from. Now what do I do next? This is the final step. 10 over 25 minus 5 over 25i. And we're not done yet because now we have to simplify this. Okay, I can, if I divide the top one by 5, I get a 2. If I divide 25 by 5, I get 5. If I divide 5 by 5, I get 1. 25 divided by 5 is 5. And here's the I. See, a lot of work. So what is A in this case? 2/5. And what is B? -1/5. And there you have, now this number here is exactly the same as our first quotient. It's just that it looks very different, but this is the process that it takes to get one of this done. I'm going to go ahead and do another one. This is going to take a little practice, okay? Let's say 1 plus I over 2 plus 2i. So 2 plus 2i, what's the conjugate? The conjugate, sorry about misspelling conjugate, the conjugate of that would be 2 minus 2i. So I'm going to multiply top and bottom by that. And here it is, 2 minus 2i. Now, I will continue to write the middle terms, but they will cancel anyways when you multiply two conjugates. So here they are, 4 minus -4i plus 4i minus 4i squared. There it is, you see, they cancel. My numerator, 1 times 2 is 2, 1 times -2, and the I is -2i. I times 2 is 2i, and I times negative 2i is negative 2i squared. Okay, again, I squared is negative 1 times this negative comes into positive 4. Added to this 4, you get 8. Now, again, same thing. I squared is negative 1. That negative 1 times this negative 2 is positive 2. Then you add it to this 2 and you get a 4. And then in this case, it just also, they cancel. The middle terms in this example cancel as well. Okay, so what do we have left? What we have left is something very simple. In fact, I don't need this humongous division sign. Okay, and I need to write this 8 here. And I simplify this. Notice that there's no i's. So what is this? What is that? This is equals to 1/2. Okay, now if you want to be technical about it, you can write 1/2 plus 0i, and that will be fine. Okay, now let me show you where that 1/2 also can appear. I'm going to show you something here, and you will see that everything that I did is correct. There's nothing wrong. It just happens that way. Look at what happened here. This is the original problem. Okay, well, guess what? The denominator I can factor out a 2. And then this cancels. What's left? 1/2. You see that? It's the same thing as what we got here. Now it just happens that in this case you were able to factor a 2, and the numerator and the denominator actually, we tend to say they cancel, but they don't cancel. What happens is that it gives you a 1. This is actually a 1. Okay? And of course 1 times 1/2 is 1. Let's do another one. Let's do this 2 plus I, and then we have 1 minus I. So what are we going to do? Multiply top and bottom by the conjugate of the denominator, which is 1 plus I. Now this time I'm not going to multiply the middle terms of the denominator. I'm just going to multiply 1 times 1. Negative I times I is negative I squared. Where are the middle terms? They're going to cancel anyways. So why are they going to cancel? Because they're conjugates. That's why. Now the numerators, I have to multiply everything. 2 times 1 is 2. 2 times I is 2i. I times 1 is 1i. And I times I is I squared. There. Now, this is equals to negative 1. Negative times negative positive. Plus, so what you have here is plus 1. So you get a 2 here. Okay, so the denominator turns into a 2. In fact, let me do it in slow motion. 1 minus minus 1, that becomes 1 plus 1 equals 2. Okay, so that's my denominator. Now, what is my numerator? What is my numerator? My numerator will be, again, this is negative 1. 2 minus 1 is 1. 2i plus 1i is 3i. So how do I write this in standard form? So I write 1/2 plus 3/2. Now the I should go in the middle, not below the line, and you can put it above or in the middle, but never here. Don't put it there, because then if you do, then that will mean something else. All right, so in this case, A is 1/2 and B is 3/2. So this is the real part and this is the imaginary part. The imaginary part will always contain the I. Okay, so this gives you an idea and how to multiply, divide, subtract complex numbers. Okay, so I hope this is helpful, and make sure that you complete these assignments in Alex. Okay, all righty, thank you. I'm going to start recording right now.